Hello, pre-algebra students. This is Mr. Underkoffler, and today we're looking at the guided notes called Volume of Pyramids, Cylinders, Cones, and Spheres. We're going to start right off with the difference between pyramids and prisms. Now, some of this we already talked about before, but let's review. Pyramids have one base, and the other sides are triangles. Prisms have two bases that are parallel and congruent to each other. And then the other sides that go in between those parallel congruent bases are going to be rectangles. Now, the other big thing you need to see, and I have this highlighted for you on my screen, is that the volume formula of a pyramid is 1/3 times what it would have been if it was a prism. So you're already used to, on the other packet of guided notes, volume of prisms is the area of the base, that's capital B, times the line segment that goes in between them. We normally call that the height. That's your standard formula for any type of polygonal prism. It could be a trapezoidal prism, triangular prism. But for a pyramid, it's 1/3 times the area of the base times the height. Everything else is going to be the same. Now, on these drawings, we have a triangular pyramid because the base is a triangle, and then we have a triangular prism because the top and bottom are parallel congruent triangles. What I recommend that you do, and we talked about this earlier with the other guided notes with prisms, is I recommend drawing a sketch real quick of the base. So here we have a triangle. I draw a quick sketch. I need for the area base times height times 1/2. So what's the base and the height? They're the two things that meet at a right angle. Doesn't really matter which one you call the base and the height when it's a right triangle. So substitute those in. Formula substitute solve. You get the area of your triangle. Put that in for capital B. And then the height. I want to point this out to you. The height of a pyramid will actually meet at a right angle to the base of the pyramid. Now, this pyramid is a little weird. It's kind of upside down. The base is at the top. Normally, you think the base is at the bottom. Sometimes it's going to be in the front or the back. Sometimes it's going to be at the top, like on this drawing. But here's what you need to know. The height will be a dashed line that meets at a right angle to that base. So that was the 9. So that's my H, which means I didn't even need to use the 10 at all. That 10 was just a line segment right here, which was kind of this is actually side C if you're thinking Pythagorean theorem. But I don't need that for area of the base, and I don't need it for the height, so it's just going to be ignored. So formula substitute solve, boom, my volume is 72 cubic feet. You would do the same thing if it was a prism. You'd draw a sketch, find your area, find your height. It's the line segment that goes in between the triangles. Put that in. But here's the difference. Prisms do not use the 1/3. Pyramids do use the 1/3. So I don't know if you want to put a star here or write yourself a little note. I already have it up here at the top. Pyramids use 1/3. Prisms do not. Everything else is pretty much going to be the same with your work. Now, speaking of using a 1/3 and not using a 1/3, let's talk about cones versus cylinders. Cones are 1/3 as much of a cylinder. So a cone will have a 1/3 times pi times radius to the second power times height. Cylinders do not have the 1/3. Their volume formula is just pi times radius squared times height. Kind of like pyramids versus prisms, cones only have one base. Cylinders have two bases, which are going to be parallel congruent circles. So that's kind of like what we had at the top of the page with pyramids versus prisms, kind of similar with cones and cylinders. The one thing you don't have to do here that we did do with pyramids and prisms, you don't really have to draw a picture of the base. We know it's going to be a circle. You just need to make sure that you have the radius. So if you're given diameter, you'll have to divide it by 2 to get the radius. But on the sample drawings I gave you here, these are the radiuses. So I simply substituted them in. No big deal. And they will be taken to the second power on both the cones and cylinders volume formulas. And then I think you're not going to have any problem finding the height. That's pretty self-explanatory on both of these pictures. Let's quickly talk about the sphere. The sphere has no base. It is just a ball. It does not use 1/3 and it doesn't have height. it uses 4/3 times pi times radius to the third power. So I don't know if you want to put a star here on your notes. This formula uses the third power, and it's because it doesn't really have a height, so it's like an extra radius. So instead of r to the second, it's r to the third. So anyway, pretty simple formula substitute solve. You just got to find your third power key on your calculator. You'll probably use the caret key if it's a TI-30X2S calculator. The Texas Instrument calculators, they have a caret key, and then you'll tell it to use the power of 3. So not really that big of a deal. There's your sphere. Okay. The next page has a bunch of practice problems, 1, 2, 3, and 4. If it's a pyramid or prism, I recommend drawing a sketch of the base. Unless it's a simple problem like number 4, you'll see what I mean when you get to that one. And then number 5, we're talking about spherical, which means sphere. You don't need to draw any picture at all. Just use the correct formula for the sphere. It also has a part B. And then number 6, we have a cone, and then we have a cylinder and a cone put together. So that's going to take a little bit of work. But you should be able to do this on your own. You have sample drawings on the first page to look back at. So hit pause now. Do all these practice problems, not just 1 through 4. Also do numbers 5 and 6 on your own. But don't do the final page. That one we'll save for afterwards. So 1 through 6, try them on your own, and then hit play when you're ready to see how you did. All right, did you already do 1 through 6? If not, you got to hit pause now, because you got to do these problems on your own. Independent practice is an important part of math. All right, I'm assuming you already did 1 through 6. If not, you better hit pause, because here I go. This is a square pyramid. So pyramids use 1/3. Did you draw a quick sketch of the square? It's 7.5 on both sides. So you can just do s to the second power. You can even do length times width if you accidentally use the rectangular formula. Not a big deal. That's going to give you an area of 56.25. Now you can substitute that 56.25 in for capital B. But then don't forget the height. The height of the pyramid was pretty clearly marked as 16 meters. Substitute that in. Boom, your volume is 300 cubic meters. Problem number 2, this is not a pyramid. This is a triangular prism, so no 1/3. If you accidentally had the 1/3, you might need to hit pause, erase it, modify your final answer. So if you have to do that, feel free to hit pause if you have to. I would draw a quick sketch of the triangle, so that way you can find its area properly. This was a right triangle, so the base and the height are the two measurements that meet at the right angle. Formula, substitute, solve. The area of the triangle is 360. Now you can substitute that in for capital B. How did I know the height was 55? Well, because the height is the line segment that goes between the two triangles. So that was the 55. Put that in for the H. Formula, substitute, solve. The volume of the triangular prism is 19,800 cubic feet. All right, problem number 3. This is a pyramid, so it will use the 1/3. Now, the base is the triangle at the bottom, so let's draw a quick sketch of that. Label its measurements. Notice the right angle here. So we want the two measurements that meet at that right angle. That's the 8 and the 6. So I labeled that accordingly. Formula, substitute, solve for the area of the triangle, and you get 24. Now, if you accidentally use the 10, hit pause in the video, fix it. That 10 did not meet at a right angle. That's how I knew it was not the lowercase b or the lowercase h. All right, from here, we can now substitute it back into the volume formula for capital B. Make sure you have the 1/3, as I said earlier. Pyramids get the 1/3. The height was pretty clearly marked as 20 feet for the height of the pyramid. Substitute that all in. 160 cubic feet is the volume of the pyramid. If your answer is 3 times as much, you probably forgot to multiply by 1/3. If you accidentally multiplied by 1/2, then obviously your answer would be a little bit bigger, so double check your work there. All right, moving on. Problem number 4. Normally with prisms and pyramids, I recommend drawing a quick sketch of the base, but no need to here. Capital A is area. They are giving you the area of the base, so you can put that in for capital B right away. No additional work needed. And the 10 is definitely the height. Did you have 1/3? If you did, you should get a final answer of 160 cubic inches. Is that 2 answers in a row of 160? Well, look at that. That's kind of funny. That was unintentional. Anyway, moving on. Problem number 5, we got the spherical scoop. That's the adjective form of the word sphere. If you didn't know that, and therefore you didn't know what volume formula to pick, then hit pause now and quickly do number 5 on your own, and then hit play when you're ready to see how you did. This problem's a little tricky. They did not give you the radius. They gave you the diameter. You're going to have to cut that in half, divide it by 2, and substitute that in for the R. 6.3 divided by 2 is 3.125, or sorry, not 125, 3.15. That is your radius. Make sure it's taken to the 3rd power. Now, you can enter this all into your calculator at one shot, but if you didn't get the right answer, maybe you want to double check. Did you accidentally take it to the 2nd power instead of the 3rd power? I don't know. You got to check. Did you properly use 4/3? Did you multiply by pi? All those things rounded to the nearest 10th should have given you 130.9 cubic centimeters. If not, double check. Maybe do it in your calculator a second time. Part B. If the ice cream melts at a rate of 2.1 cubic centimeters per minute, about how long, so about means you're going to probably have to round here, would it take for the ice cream to completely melt? All right, so I'm going to take my answer from part A, divide, because it's melting at a rate. So I have my rate, I have my volume, divide, and you will get the amount of time it's going to take to completely melt. That's going to be about 62 minutes. Now, it doesn't really tell us what to round to. So if you said about 62 minutes, I would not mark it wrong. If you round it to the nearest 10th, like I did, that's fine as well. And instead of using the approximately equal to symbol, you could actually use the word about. That'd be totally appropriate. All right, last problem. This took a lot of work because you got to do the work for the standard funnel, which is a cone, and then you need to do the work for the 2 parts of the Buchner, whatever you call that funnel. It's a cylinder and a cone. So let's check that work. For the standard funnel, volume equals pi r squared h. Now, did you realize that they did not give you the radius? This right here is the diameter. You have to cut that in half to get a radius of 24. Taken to the 2nd power. I have a typo here. There should be a 1/3. I'm sorry. So forgive me. There should have been a 1/3 up here. That is a typo. Forgive me. I should have a 1/3 up there. My mistake. Pretend I had a 1/3 there because the standard funnel was a cone. So that's 760 pi. Now notice, I didn't round that. You could have multiplied this into your calculator. And if you did that, I can do this real quick with my calculator as I'm recording this video live. 7,680 times pi will give you about 24,127.4 cubic millimeters. All right, for the Buchner funnel, we're going to do pi r squared h for the cylinder, but then we're going to do 1/3 pi r squared h for the cone. All right. Did you realize the radius was 17? Because on the drawing, they gave you the full length across, which is the diameter. You need to cut that in half. We have 2 different heights here. 20 millimeters was the height of the cylinder. 18 millimeters was the height of the cone. All right, formula substitute solve. The cylinder is going to be 5,780 times pi. The cone is 1,734 times pi. Add those together. You get 7,514 times pi. Now, if you want to know what that number is, for those of you who actually got the decimal, that would be about 23,605.9, which was smaller than 24,000 number that the standard funnel would be if you made that a decimal as well. So what's the final answer? Well, the standard funnel, whether you had it in terms of pi or whether you had the decimal version. Either way, the standard funnel has the greater volume. All right, last part of the guided notes, using inverse operations with volume formulas. You're still going to do formula substitute solve, but here's what I want you to know. Sometimes the volume is going to be expressed in terms of pi, especially if it's a cone, cylinder, or sphere. This is a possibility. In fact, number 1 below is an example where the volume is 288 times pi. When that happens and you're doing inverse operations, when you divide by something times pi, the pi's will divide themselves out. Let me show you what I mean. Here we have a sphere, so I use the volume formula of a sphere, but I have the volume, so the volume will go in for capital V. So I put that in. But I need to solve for the radius. So we're solving for r. What's happening to the radius? It's being taken to the third power, but then it's being multiplied by 4/3 pi. So inverse operations in the order of SADMEP, get rid of the multiplication parts, which is the 4/3 times pi, before you do the inverse of the exponent. So I'm going to do the inverse of multiplication, which is division. But here's what makes this interesting. 288 pi divided by 4/3 pi, the pi divides out the other pi. So in your calculator, the only thing you have to do is take 288 and divide by the 4/3. That's it. Pi keys aren't even needed because the pi's divided themselves out. So that would give you 216. Now, let me introduce you to a brand new inverse operation. The inverse of taking a number to the third power is the cube root. You guys have seen square root before, but have you seen cube root? All right, how do you get this? Well, I think the Casio calculators actually have a cube root key. You're going to have to find it on your own. But what about the Texas Instrument calculators? What they have is an X root key. Now, let me clarify. Square root key is above x to the second power, but X root is above the caret key. You can use this for any root that you need, including cube root. But you have to tell your calculator what you want the x to be first. So the first thing I do is I punch in 3. Then I hit my second function button and then my caret key to get the x root to show up on my calculator. But I made sure I put 3 in first. If you don't put 3 in first, it's going to put A and S, which means whatever the previous answer was is going to be your root, which you don't want that to be. You want it to be the cube root, the third root. So put 3 in, then X root, then 216. Should look like this in your calculator if you have a TI-30X2S, or some other Texas Instrument calculators will look the same as well. And you should get the answer of 6 meters. Now, will you always have pi's dividing out pi's? No. Here I give you an example where the volume is not in terms of pi. So it's just this ugly decimal. Put it in. Find your radius. Remember, the radius is half of the diameter. So I took half of the diameter, divided it by 2, got a radius of 8. I do as much work as I can. This part right here, I do, but I keep it in terms of pi. And I divide on both sides. Now, if you're wondering, yes, the parentheses are necessary. If you try this without the parentheses, you will not get the correct answer. I think there's one exception. I think there's one type of Casio calculator that, strangely enough, will give you the right answer. I don't know why. But all other calculators, if you do not use the parentheses, what your calculators will do is it will divide by 64, then get an answer, and then take that answer times pi, which is a much bigger number than 20.5. So bottom line, when you're dividing by a product, something times pi, that's when you need parentheses. I even used it in number 1, even though the pi's divided themselves out. So I'm going to look in your work. When you divide by something times pi, I want to see the parentheses. It is a must. Okay. And then I gave you one more example here. This had nothing to do with pi. This was a rectangular pyramid. I did do the work off to the side to get the area of the rectangle. So here's that work. Except I never knew the length. The length was the unknown. Find the length. So I have the width. Length times 3, that's just 3L. Put that in for the area of the base. And then do as much work as you can. 1/3 times 3 is 1. 1 times 6.8 is just 6.8. Inverse of multiplication is division. And I get the length. Oh, I forgot to say, the volume went in for V, as it did for numbers 1 and 2. All right, now that I talked you through numbers 1, 2, and 3 for the inverse operations problems, I would like for you to use them as a guide and do 4, 5, and 6 on your own. Remember, sometimes the volume will be in terms of pi, other times it won't. Keep that in mind. Know when the pi's are going to divide themselves out and when they won't. And go ahead and do 4, 5, and 6 on your own. So hit pause now, do those last problems, then hit play when you're ready to see how you did. All right, did you already do 4, 5, and 6 on your own? If not, better hit pause now because I'm about to go over it. Problem number 4, this is a cone. I almost said cylinder, but it's a cone. So do you have the 1/3? If not, you're going to have to edit your work. Maybe hit pause right now. Substitute. We have 1,800 pi going in for V. We know the radius is 15. This was not diameter. This was radius. So that goes in for R. Do as much work as you can. So 15 to the second is 225 times 1/3 gives you 75. Now keep that in terms of pi. Do not make that a decimal. Divide by that on both sides. Pi divides out pi, which means the only things you have to do in your calculator is 1,800 times divided, inverse multiplication division. Divide by 75, and you will get the answer for the height. Boom, 24 inches. And notice, height, radius, length are normal units of measure. They are not cubic inches. Volume would be cubic inches, but height, radius, length, width, they are regular inches. Okay, problem number 5. We have a cylinder this time, so no 1/3 is just regular pi r squared h. No 1/3. This volume is not in terms of pi. All right, 7 to the second is 49, so we have 49 times pi. We're going to divide by that. Yes, the parentheses are required. If you don't use the parentheses, you will not get the correct answer. You'll get something much larger. So use the parentheses keys not only on paper, but in your calculator as well. 32.8 if you round to the nearest tenth, regular inches. Finally, number 6, a mini basketball. What shape is that? It's a ball. So it's a sphere. Substitute in the volume. Now, why do I have the pi crossed out already? Because I'm already anticipating the rest of my work, where I do the inverse of multiplying by 4/3 pi, which is dividing by 4/3 pi. Pi divides out pi. So in your calculator, you really only have to do 73 divided by 4/3, which will give you 54 3/4. Now, from here, you might want to use that as 54.75. You could keep it 54 3/4 if you want. Inverse of third power is the cube root. Remember how we get that in our calculator? We have to type in 3 first, then hit second function button, caret key to get the x root. If you have a Texas Instruments calculator, if you have a Casio calculator, you actually have a cube root key. Cube root of 54.75 is about, if you round to the nearest tenth, 3.8 meters for the value of the radius. All right, that concludes the guided notes on volume of pyramids, cylinders, cones, and spheres. Thank you for watching. We'll see you next time.